Hello, everybody. Thanks again for joining us. As usual, Dirk Wood here from Parallaxis. Do about a 25-minute podcast. Today, we are super lucky to have out of Belfast George Glass, who is the CTO of the TMF Forum. Now, some of you might not know who the TMF Forum is. They are a global industry association of telecommunications service providers and suppliers. They represent over about 800 member companies, 10 of the world's largest telecom providers. Collectively, they generate about $2 trillion in revenue and serve about everybody on the company in the world, about 5 billion people or so, over 111 countries. And so super lucky to have George with us today. George, thanks for coming.
Pleasure, Dirk. Great to see you again. Pleasure to be with you today.
Yeah, and George and I used to work years ago at BT out of London. Lost track of George for a few years, but glad to reconnect. And so we've got about 10 questions or so, and I guess I'll just get us kicked off. The first one's kind of around technical vision and strategy. So George, the TMF Forum has evolved, its strategic focus in kind of three key missions. Can you walk us through this structure and explain why AI and data have become a foundation layer supporting everything else?
Yes, so the TM Forum, we've been an association, we've been around for 35 plus years. We were probably famous for SID and ETOM and TAM, which is what many telco professionals will recognize and remember us for. But 6 or 7 years ago, we started to change that with the introduction of our open APIs and our open digital architecture. We started to become and transform ourselves into the reference architecture and go-to place for telecoms IT transformation. And then that has evolved further. And in the background, unbeknownst to maybe the general public, we were working on two other areas of interest. We were working on autonomous networks, leveraging the fact that the network was becoming software. And we were working on AI. And we've been working on those two programs in the background for about 5 or 6 years. And then earlier this year, we revised our strategy and we actually set out to drive the forum using what we call three missions. And those three missions are composable IT and ecosystems, autonomous networks, and AI and data innovation. And you can see the composable IT and the ecosystems lands very nicely with the heritage of a telco trying to transform its IT and expand beyond its boundaries, offering connectivity services as part of an ecosystem solution. The autonomous networks kicked off because we recognized that networks were becoming software, and actually the principles and the policies and the design patterns, the abstraction techniques that you applied to managing software at scale in the IT domain could now be applied to networks. And we started to look at how do we manage and think about how you manage networks differently. And that was our autonomous networks program. And through this podcast, we'll probably explore a little more detail about that. And then we were working on AI because we realized that the complexity of what we were managing, the number of data points, the information that we could derive from that data was growing exponentially. And no human brain or process or manual activity was capable of keeping up and keeping pace with it. So that's where we introduced the concept of AI. And initially, it was the natural evolution from data analytics to machine learning to predictive AI. And then in 2023, early in that year, ChatGPT emerged, and suddenly the world was excited and interested in AI. Unfortunately, we already had a 3 or 4 year head start. So we had already been thinking about the guardrails that you need around building AI in a telco, the frameworks that you need, the information models, the controls, the permissions, and so forth. And our AI program that we've been developing, which was around predictive AI, then started to embrace generative AI and is now encompassing agentic AI and the whole agent to system, agent to people, and all of that, what goes with that. So that's given the forum then these three key areas: composable IT and ecosystems, autonomous networks. Both of those missions are underpinned by our AI and data mission. That is the foundation of pretty much everything we do. And all of those things are then encompassed and enclosed within our open digital architecture, or ODA. And it's the pattern that we use, the architectural pattern, for the abstractions, the decoupling of the components, and the exposing of the business capabilities from those components via the industry standard open APIs.
Wow, interesting. Thanks for that, George. And yeah, we will dig into some of those going through here today. So there's also a lot of talks about networks as software, excuse me, and intent based networking. Can you maybe walk us through what that actually looks like in practice, and how close we are to users simply requesting outcomes rather than specifying technologies?
Yeah, that's the real crux of it, Dirk, and that's the thing that's going to change how you actually think about how you manage your network in the future. As the network becomes software, it's no longer a set of physical resources that had their own bespoke chipsets and operating systems to deliver this highly resilient, highly available component of a network, but completely fixed, completely static. And a lead time of maybe 2 to 3 years to change the functionality of that component, or to add an extra couple of bytes to the interface if you're trying to pass a message between the components. Networks are becoming software. They can run in the cloud, and therefore the actual network resources and the functions of those networks are actually bits of software that need to be managed as such. And that's where we started to look at that and say, well, okay, if I can start to abstract the network and manage it as a set of software resources or software components, I need to also change the way I think about how I actually sell those network services to the customers and the users that consume them. My challenge to you today is that we're on a call today. Do you actually care what type of access that we are using to connect us so as we can sit on this bridge? It could be Wi-Fi, it could be fixed broadband, it could be mobile. We don't really care. What we care about is that there's a clear video picture and there's clear audio. So we've got an intention. We want to have a video conference. We want clear audio and we want clear video. I have not specified anything about the network technology that I require or want to deliver that service, nor should I care about it. And this is the move that I'm trying to drive is get the telecoms operators to start selling connectivity as a service, not selling technology. So I take the request that you and I have, and through that's an intent. That's what we want. We want an outcome of a clear, uninterrupted video conference. I take that and I translate that using my intent ontology into a set of service characteristics. What do I need for that to be true? And I get something like 15 or 20 megabits per second bandwidth. I've got a 250, 500 milliseconds latency in terms of the persistence of the network. And after that, I take those service characteristics and then through my discovery in the network, say what access technology could deliver that and select the appropriate access technology to deliver it. So suddenly I've taken an intent-based request from a user, you and I've translated that into a set of service characteristics, and I've used those service characteristics and an intent-based request at that level to actually eventually configure, in my case, a broadband connection that's going to deliver a seamless podcast. So it's becoming a reality. We're starting to see our members delivering and designing services that start to talk from a natural language and a description of what the user wants, translating it into service characteristics, again, an intent based request, and taking that intent based request and translating that into an actionable resource based activation or control on a network device. And that's where we're trying to get to. And that's where you can start to take the idea of selling network technology and change that to selling connectivity as a service.
That's interesting, and that network orchestration is so far advanced to where we used to be back in the PT days. Um,
Absolutely, yeah.
it took ages to change those things. I guess so. In doing that, let's say, like you said, you mentioned, the network intelligently chooses Wi-Fi, 5G, satellite, UDP, TCP, whatever. What sort of AI models are proving most effective at these real-time decisions?
So it's interesting because everybody has jumped onto the agentic AI bandwagon. And I'm actually still looking at it and saying, for the services that we're trying to deliver, it's a combination of different AI technologies that I need. For many of the services that we're trying to deliver, actually a rules based orchestration works perfectly adequately. If I've got multiple access domains and they've got different service characteristics, and I'm trying to dynamically reconfigure my connections in real time, then I start moving into a sort of predictive AI. But once I have actually made the connection and said, right, I'm going to select broadband, I will also use an agentic capability to discover what other technologies are available to and actually set those up and monitor those in real time, storing effectively a memory that I've got those other capabilities available to me, so that if the current connection that we're on starts to degrade or fails entirely, that intelligent orchestration layer that's now driven off a set of agentic machine to machine communications and monitorings that's monitoring my other connections can now make an intelligent decision that the current access connection on my broadband is no longer sufficient. What technology can I switch to? And will select an alternative technology. And again, now what I've done is I've used a mixture of an initial REST-based request to set up the set of services that I have running at my premises. I've used a set of agentic predictive AI capabilities to determine which AI or which access I use. And then I'm using agentic AI to monitor the different connections and then use that to drive the selection of another predictive AI connection to work out where I switch to. So I'm getting a real mixture here going on in my network. And it's not just everything becomes an agent, everything becomes MCP, everything becomes agentic. It's like there's a balance, because one of the things I'm warning against is that my experience of designing networks means that the agentic components generate a lot of chatter between each other. And if I've got multiple domains and agents running in every one of those domains, and they all start chatting to each other, what you'll actually find is the performance of the network to actually deliver the traffic that I want, i.e., our audio and video connection, is actually degraded because the network is spending all of its time generating all of this admin chatter between the agents just to try and tell the other agents what's going on and what the current status is. So we need to look very carefully at the network topology and the design of the network to ensure that, yes, in the conceptual idea of a lab, you can make this agent to agent agentic network, but in the practical reality of the operation of a very large scale network with millions of nodes, that may not be practical in terms of the administration overhead of managing the agents compared to the ability to actually deliver the data and information that I'm trying to yet use the network for.
Yeah, that's interesting. That's actually a piece of gold right there for people listening. I mean, you don't want so much chatter that you're actually degrading the service that you're trying to get to your customers in the first place. So one thing I know, George, is a lot of people's mind with a lot of what's going on is privacy around AI capabilities. How do you see? I mean, any examples that you might have be great, but how do you see in the future networks potentially using AI on their own to perhaps detect and protect sensitive information that's going through the network?
Yeah, so we're already seeing that in early stages. If you try to send an email, I know within our organization, if I send an email and it has a set of names, telephone numbers, and so forth, it'll give me an alert saying, George, you're transferring what potentially could be sensitive personal information. Are you wanting to do that? So I'm already, that's probably a rules based activity that's actually monitoring the network traffic on my email. And that's quite slow. So that's okay. Everybody can understand how, with a rules based system, you can say, look for this type of data. This is sensitive personal information, uh, private information, whatever. But why can't I actually take that logic and go a stage further and start with my AI models and start to build the capability to listen in and monitor to the conversations? And actually, if you start talking about making a payment and transferring bank details and reading out credit card numbers, immediately then you think, right, okay, what I need to do is I need to change this connection from an open connection to an encrypted connection so that I'm only going to transfer. Or if I'm running a co-pilot on the session, that I immediately stop the recording so that I don't record the bank details that are being shared. So you can start to see by taking the basic concepts that we had on a very slow network, which is the transfer of emails and inspecting the email, looking at the contents and giving an alert, to actually take that logic, multiply it by a factor of a million in terms of performance and response and processing capability, and start to actually monitor the conversation and make decisions on that. Because let's face it, we all have Copilot running constantly whenever we're on our conference calls, on our Teams calls, or whatever. So we've all got an AI agent that's listening to everything because it's transcribing it, it's making notes on it. Well, why can't it just put some intelligence into it and start to say, hang on, start training that agent to say, these are sensitive things, start to give alerts. And we would even have it internally in an organization whenever you're having a management meeting and you're having sensitive conversation about employees in the team. You'll ask somebody to leave the meeting because they're not at the appropriate other level or whatever, or it's security clearance to understand the conversation. Similarly, whenever you're actually having those conversations, you have to remember to switch your chat GPT, Copilot, AI agent off so that you don't inadvertently record those things. I can see that over a period of time, they'll become more intelligent and they'll immediately flag up to say, I'm still here, I'm recording, just as you would ask maybe if you're talking about security information, a non-security cleared employee to leave the room while you had that conversation. Then similarly, there's no reason why an intelligent agent can't behave in that way, and we can train the agent to behave in that way. And I can start to see where suddenly our networks will start to encrypt themselves where they need to be open when they can be, and actually change the characteristics of the network service based on the conversation that's happening or the traffic that's flowing over the network.
Cool. Wow, interesting. So the next topic, I kind of want to move into industry leadership, global perspective, and maybe not so much the technology, but what you think, George, as a leader in this industry. So obviously, you work with operators all over the globe. I know you from BT, but I was at Quest Communications. I was at Level 3, network operators all over the globe. Where are you seeing the most impressive implementations of autonomous networks, AI-driven infrastructure? Insert whatever cool, impressive thing that you've seen,
Yeah.
and I guess what separates them from leaders who are just talking about how cool this can be, but people are actually doing it?
Whenever we're working on these areas, we've always adopted a philosophy of you take an idea, you test it, you verify that it appears to work pretty well, you build it out and you try it, and then you feedback and you work in that continuous feedback loop. And that's the way, in a sense, we've been developing our standards within the TM forum for years. We don't go off in a huddle for 3 years and then publish a 500-page document, say, here's the standard. We actually build it, test it, run it, refine it, build it, test it, run it again. Normal software engineering, minimum viable project type approaches. And that's where I look at across the world whenever I look at autonomous networks, where I look at AI. Those organizations that are really getting value from it are following that sort of model. They're not just talking about it, they've formed small teams. They've tried or tested some of the concepts. Some of that they've done it in Catalyst programs with us in the TM forum. They've learned from others. They've then applied it into their environment, following their rules, their constraints, using their data, monitored what they've got, and then refined it and developed it further. And we've seen across the globe in AI that pattern being repeated. And we're starting to see some very impressive results coming out from organizations that are actually building AI into their processes, changing their customer experience, changing their network monitoring and network management to deliver unbelievable outcomes. And the same with our autonomous networks. For our autonomous networks, the approach that we took, having defined the different levels from level 0 through to level 5, and level 4 is where you start to hit the full autonomous network. What we actually did was saying, look, I cannot go to a tier 1 operator and get them to transform their entire network landscape to AN level 4. That's just not going to be practical. So what can I do? What are the high value scenarios? Where are the the processes that give you the most pain, that if I could deliver an autonomous solution in that space for that technology, you would get the maximum benefit. And we've done that, and we've mapped out 50 or 60 different areas. And out of that, we've identified 20 high value areas. And one area that comes out over and over again is fault management, either in the core, in the RAN, or in the IP world. And what we've seen is members have taken that, they've measured what their current business indicators, effective indicators are in terms of what are they getting today. They've then worked with our design patterns for how do I take what I've got, which is an automated or a semi-manual stroke automated network, and translate it into an autonomous network, which has intent, which has the closed loop controls, has the intelligent orchestration for that domain, for that technology. And they've designed that and built that out at AN level 4. They've then deployed it and scaled it up and measured the outcome that they received. Did they get the business indicators that they had predicted? Did they get the key effective indicators? In the fault management, was the mean time to repair reduced by 70%? Were the number of faults that were actually customer affecting reducing by 40, 50%? And if they started to get those, then it was like that was the evidence that they were building out AN level 4. Now that's in one domain for one technology. So then what we do is we work with them saying, okay, we've got a showcase going on at the moment with our members coming together to say, take your fault management in the IP space, in the RAN, in the core network. Let's join those all up and say, how do we do fault management consistently across your organization? That's technology agnostic, that's independent of the domains, that actually allows you to do fault management at scale across your entire network. And we'll build that out. And we're hoping to showcase that at DTW 26 in June in Copenhagen. Wall to wall fault management across all technologies in the network space. That's the way we work. And that's whenever we see members doing that, they're actually achieving unbelievable results from the first stage implementation. So they don't try and boil the ocean or eat the elephant. They actually boil a cup of tea and they drink that. They eat the toenail of the elephant because they know they've got the whole thing to eat, but they're starting small and they're building on that step by step.
Yeah. It's been about 10 years since I've been in telco, but it seems like you finally got him, George, to not eat the elephant
Yeah.
because the elephant was all they used to
Yes.
eat. Uh, well, cool. So a couple more questions. So, I mean, there's one still kind of on industry leadership and whatnot. In terms of hyperscalers, so there does seem to be a significant gap around hyperscaler success and traditional telecoms and their profitability. Are you seeing any innovations that are helping operators compete more effectively?
It's a great question, Dirk, because it depends on where in the world you are as to whether how I answer that question. Because what I actually see in Asia, particularly in China, is that the Chinese telecoms operators are also the hyperscalers. So they still are selling the compute and storage on demand, and they are just you know, as an operator when I was in that organization in the UK, we used to sell hosting, but then very quickly realized we couldn't compete with the hyperscalers because we had 20 or 30 million customers and the hyperscalers were going global. In China, the Chinese operators have 900 million customers. They sell to the government, they sell to industry, and they provide hosting and storage and compute. They actually have what they call ACN, Autonomous Computing Network. They join the autonomous network and the computing together and they sell that as a service. So in those areas, the telecoms operators are as profitable as the hyperscalers because they are the hyperscalers. In the West, in Europe, and in the US, what we actually see is the hyperscalers have taken that hosting cash cow away, and therefore they're running that at scale. And actually, the operators, the telecoms operators, are all running their services on the hyperscalers and giving them even more of their margin. So it's just depending on the operating model and obviously the scale you run at, because I don't think as a 20 million customer organization you can compete with a hyperscaler if you're trying to provide hosting services. It's just not possible. And on the network, we need to be very careful because the connectivity, yes, it's geographically constrained to provide the access in the last mile, but the rest of the actual global networks, maybe you'll find that you get a better global network from a hyperscaler than from telco. We need to, in the telecoms industry, be very aware of that and make sure that we are developing our global networks to be as standard as possible for the interoperability, the management, and the operation of those networks to be completely standardized to simplify the interconnectivity between countries so that the telecoms are relevant globally.
Cool, cool. Thanks for that. Appreciate that. So so future technologies, and so this one is more of kind of what do you think, what you're feeling, what is your spidey sense telling you? But I want to talk a little bit about 6G and beyond. So there's research around today that's saying, it's not transmitting just data, but potentially other things like sensory information, and emotional context, and a few other things too. But I think that there's nobody probably better placed to answer the question: is this realistic? Is this, or is this, kind of hype? I guess, and I don't know, but I'd be interested in your take, George.
I think if you actually look at what's happening, obviously what we do is every time we can increase the bandwidth on a connection, we will very quickly develop applications that use it all up. And what I'm seeing with 6G, which is probably going to deliver on the promise of what was expected in 5G, which is ultra high bandwidth, ultra low latency, very dense coverage, effectively ubiquitous network coverage. But we talk about doing virtual meeting rooms, and the ideal way for that would be teleportation. So that rather than you and I just having like sound and video connections, what if we could actually appear to be in the same room together? And therefore you do holographic translation. So you've got a hologram of you and I sitting in a room, and you could interact naturally. Well,
I
that
think of,
takes you
I think,
part of the way, but what if you could then actually like reach out and touch somebody and feel something in that room? So yes, for a meeting, that's probably not that interesting. But if I'm actually going to try and do repair on a network so that I can actually, or I'm going to do remote surgery in something, that I could appear to be touching something and actually feeling and getting a response back from it. So not only do I need to transmit the audio and the video in 3 dimensions, but I can actually transmit the feel as well. Then I can suddenly move myself from one location to another, or almost move myself from one location to another. And I think those are some of the very interesting things that as you let the guys with the wacky ideas loose on a network that's got even greater capacity than we could even think about, and start to build in sensory responses along with high definition video, there'll still be the requirement to significantly compress it so that I've got space for these other messages that I want to send. I want to send the sensory messages so that I can actually get feel. Now, at the moment, it's a bit clunky because to get that, I would probably have to put on a suit at this end that would allow me to feel the response at the far end. But
sure.
can I change that? Can I get some sort of implant that will start to then respond to the nerves in your fingers to send messages to supplement your brain power, and actually start transmitting that over the network? It's a bit of a scary thought, but you start to see some of the capabilities whenever you see experimentation locally, and then think, well, actually now because of the bandwidth, there's no reason why that can't be remote, and it can actually provide an enriched experience.
Yeah, that's interesting. That's kind of crazy. It reminds me of, almost like the hologram, the Star Wars. You got the Emperor and the other,
Yeah,
and also I can't think of the name of the book I read, but it was, same thing about putting on a suit and sensory information and stuff like that. Kind of crazy to think that we're at the place where that could, be real sometime soon. So I appreciate, giving me as much time as you did. So maybe just a couple more questions, if it's okay with you, George. So,
yeah, sure.
so kind of move into industry evolution and strategic insights. So, um, some people might agree with this, some people not, but I'd say the telco industry has a history of being ahead of its time in certain areas, certain
Mhm.
concepts. And I haven't been in telco for about 10 years, but what ideas 10 years ago did we think that's just not going to happen? That's impossible. But you are actually now seeing it become viable, with the current technology.
I think one that's absolutely fascinating, and this is something that I was sitting in a meeting in China that I tried to cobble together, which is simultaneous translation. So if you take language, I can speak and I can do a speech to text very easily. I can do English text to Chinese, and then I can do Chinese text to speech. So there's nothing to stop me now with the knowledge and the AI capabilities of actually speaking and actually somebody in China understanding what I say in Chinese and them responding and me understanding what they've said, only hearing it in English. And we're starting to see that. You're starting to see AI enhanced earbuds that actually run against your phone where there's a processor that will do the translation so that I can talk to you in Chinese, you can talk to me, I can talk to you in Chinese, you can hear it in English, and then you'll respond to me in English and I will hear it in Chinese. And that was just like sort of unthinkable 5 years ago. I remember sitting in a conference and I was taking pictures of the slides on an iPad and trying to translate them from Chinese into English using the language translations. And I was hearing what was being said and recording it and trying to translate it into text so as I could read. And I'm thinking, I just need to join some of these things up and I could actually have it working. So I had Google Talk running, capturing in Chinese and doing a translate. And I was like, I had three devices in front of me that was doing this simultaneous slide translation and speech translation. And then just last month, I was at Innovate or at Accelerate Asia in China and was speaking at a conference. And as I was speaking, we were publishing the English at the top of the screen and the Chinese translation in real time as I spoke at the bottom of the screen. And the people that were listening had earbuds in and they heard me speaking in English, or else they switched to the Chinese channel and AI was translating it to Chinese. And the translation, you looked at it and you smiled at it. The remarkable one was one of the Chinese guys got up to speak and said, I'm very pleased to be here today. And the way the Chinese translated it was, I'm tickled pink to be here today. And then, as he said more of the sentence, it removed the tickled pink and changed it to pleased. So, whatever words that he said in Chinese, the literal translation came out as I'm tickled pink to be here today, which is obviously not what he said. But it's
Right.
just you could actually see as the sentence and the context of the sentence built up, it translated it into business English from the direct translation of the words that he had said. And I'm going, that was not possible 5 years ago. And now it's a reality. You're actually seeing it at conferences. You used to have translators sitting in little booths at the back doing the translation and everybody had earpieces. Now it's just happening. And I was at a conference where a chap who was a native German speaker was delivering his speech in English and the translation was coming up in Arabic because it was in the Middle East. And midway through his presentation, he switched to German, which was his native language. It started to show the German at the top of the screen and continued to show the Arabic output at the bottom of the screen.
Wow.
And it's one of the few times when I've been sitting in a telco conference when there was a spontaneous burst of applause from the audience. Because it's just like, wow, that was pretty impressive. And that was all AI translation driven from speech to text and doing multiple language translations in real time.
Wow. I mean, that's the universal translator from Star Wars, from Star Trek, right? I mean, you get the UN and you can,
Yeah.
translate it from German, French, English, Portuguese, whatever
Yep.
you might want at the same time. That's really cool. Um, so one more for you, George, if you got the time. So, as you know, obviously you work with operators worldwide. What's the most strategic shift you're advising them to stay relevant in an increasingly AI driven landscape?
I think there's two or three things that they have to do, and I think they're increasingly realizing that you need a really, really strong foundational data set where there's universal understanding of what a customer or an account or a device is. Because if you don't have that, you're actually spending an awful lot of your time translating your data to try and understand it. It's back to almost like the language translation. One operator's interpretation of this is different from other vendors and so forth. So get your data right. Make sure you've got access to that data, because what we're finding is increasingly AI functions are making use of more and more data to actually make better and better decisions. So make sure you've got access to data. Thirdly, make sure you've got permission to use that data, because increasingly you're going to be held accountable for the data that you use and the decisions that you make based on the data. And if you don't have permission to use the data, if I start to give you recommendations that you realize George can only understand this because he's looking at some data that he shouldn't have access to, then I'm opening myself up to vulnerabilities, up to prosecution for actually inappropriate use of your data. So I think it's like, get the data right, make sure you've got access to data, make sure you've got permission to use the data, and then start to build your AI models and let them loose, let them be trained, let them develop the models. So you're constantly with that feedback loop, you can enrich them and enrich the customer experience associated with using them. But it starts with the very, very basics of right data in the right place, easy access with permission to use it.
Yeah, that's what we're finding too, is the right data that is fit for purpose to solve a specific business problem.
Yeah.
For sure, for sure. Well, George, thank you so much for joining us. We don't always have as a high level folks for you with as much powerful gray matter in the brain as you are. So I appreciate you being here and sharing us your thoughts for us. So thank you so much. And everybody, obviously, the TM Forum is a hugely rich resource for folks. Be sure to look them up. And George, thanks again for being here. Can't thank you enough.
Thanks very much, Dirk. Great to see you again. Thank you.